In this video, let's talk about Lewis structure. I want to teach you Lewis structure, how to draw Lewis structure step by step. Then I also teach you the concept of formal charges. How you calculate the formal charge of each of the elements in what the Lewis structure. Not only that, I also teach you resonance structure. And if I permit, I'll teach you how to select the best Lewis structure. So this is going to be a complete video. By the end of this video here, you should be able to what, draw Lewis structure of any compound at all or any molecule at all. Then you should know how to calculate what formal charge. So step one is that you should calculate the total valence electron. So I'm going to use H2O. I'm going to pick it step by step so that I will start teaching you this stuff here. So if they should ask me how to draw the Lewis structure for what? Water, H2O. How do you do that? It's very easy. Therefore, calculate what the total valence electron. Calculate what the total what valence electron. And the valence electron of any element at all is what the group number. So once you know the group number of any element, that automatically would be the valence electron. Do you get that? Or the outermost what electron. So you can see it display on the screen here. Each element in that what various group, their own what valence electron. So for hydrogen, hydrogen is what is in group 1. So then my valence electron is 1 times 2. Now how do I get it 2? How many atoms of hydrogen do I have? Yes, it's 2. So 1 times 2 plus oxygen is in what? Group 6. Oxygen is what? Is in group 6. So it will be 6 times 1. Do you see that? So what happened here? 6. So it's going to be 2 plus 6 is going to be 8. That is my valence electron for what? H2O is what? Is 8. So that's my valence electron. So the step 2 is to place one of the elements as the central atom. Now what I want to put in mind is that the least electronegative elements in the what molecule or ion will be what the center atom. You get that? Another thing you must put in mind is that hydrogen and fluorine cannot be the central atom. Now the reason is because hydrogen can only form a single bond. You get that? Hydrogen cannot form multiple bonds. Hydrogen can only form duplex electron. Do you get that? There is 2 electrons in the atom's shell. The fluorine, the main reason why fluorine cannot be a center atom is because fluorine is what is the most electronegative element in the word periodic table. So there are stuff you want to put in mind. So when I have something like this, 2 hydrogen, 1 oxygen, it's very easy here. Oxygen will be the center atom. Do you get that? So you place oxygen as the center atom. The hydrogen as what? Side atom. This is that. So when you do it like this here, the 2 hydrogen will connect to oxygen with what? With a single bond. So this hydrogen connected to this oxygen with a single bond. This hydrogen connected to this oxygen with a single bond. Now, what I want you to understand is that 1 bond equals 2 electrons. Do you get that? 1 bond equals what? 2 electrons. So because here I'm having bond here. Then here we have 2 bonds. Now that 2 bond equals what? 4 electrons. It means that out of the 8 electrons, total valence electron I'm having for the molecule. Do you get that? I've used 8 electrons. So how many electrons will I have next? Is what is going to be remaining electron. Remaining electron is what? 8 minus 4 will go to be given what? 4. Do you get it? So this is what my remaining electron. The next thing you want to do is here that now one of the concept of one of the concept of what Lewis structure is that all atoms must have their octets. So the goal of the Lewis structure is that they should have octet electron. And when I talk about octet electron, I'm talking about 8 electrons in their atomos shell. However, hydrogen cannot have the octet. Do you understand? Hydrogen cannot have what? The octet. Why? Because it can only form a what? 2 electrons in the atomos shell. So, but oxygen and beyond can have what? Octet electron. So, whenever you look at oxygen is already having 2 bonds. And 2 bonds equals to what? 4 electrons, right? So, when checkmate it very well. So, this 2 electrons will have to go to what? Sorry, this 4 electrons will have to go to what? Oxygen, right? As a lone pair. So, 2 lone pair here, 2 lone pair here. I'm going to explain what's called lone pair. So, here I have hydrogen, oxygen, and what? Hydrogen. So, here we have 2 lone pair. That is 4 dots. 4 what? Dots. So when you checkmate it very well, 1, 2, 3, 4, which for 4 electrons here. Now it's check. This is what the Lewis structure for what? Water, H2O. Do you get that? Oxygen is having the octet. Hydrogen cannot have octet. You only have a single bond, which is what accurate. And it corresponds to what to this eight electron. What I want to do here is this. How do you calculate formal charge? What is formal charge? Formal charge is a residual what charge on an atom or element in what Lewis structure. And to calculate formal charge, which we call formal charge, is very easy. Formal charge equals what the valence electron of the what of the elements minus what lines minus what dots. Are you there? The lines means what the bond. White dot means what electrons. Do you get that? So if you want to calculate formal charge Fc of what hydrogen, it's very easy. Fc, which called formal charge of hydrogen. Remember these two hydrogen are the same, right? If you want to calculate formal charge, it's very easy. So what is the valence electron of hydrogen? The valence electron of hydrogen is what? Is 1. How many lines does it have? Hydrogen here is having one line, that is one bond, so it's going to be what? 1. How many dots does it have? It does not have any dots, so it's what? It's 0. So the total formal charge of hydrogen is 0. This is that. So remember, these two hydrogen are the same, so two they have 0, 0. This is that. The formal charge of what? Oxygen is very easy here. Now, what is the valence electron of oxygen? Is 6, right? Minus. Now, how many lines does it have? This oxygen is having what? 2 hydrogen, right? So it's going to be what? 2 plus 2 lines. How many dots are you seeing here? 1, 2, 3, 4. Here we have 4 dots. When checkmate is very well, you give what? 0. Then the total the formal charge of hydrogen and oxygen, they are what? 0, 0. So that is why it's a neutral what molecule. Do you understand? So let me explain on that one to you. So let's just say NH what 3. Let's draw the length story for what NH3. So how do we do that? Valence electron is equal to what? 1 times what? 5, right? 1 times what? 5. Now, sorry. Valence electron is what? 5 times what? 1. Right? Now, because nitrogen is what is in group 5. How many atoms of nitrogen you have here is 1. So go to 5 times 1 plus hydrogen is in what? Group 1. 1 times what? 3. Everything will give me what? 8. Because 5 times 1 is 5 plus 1 times 3 is what? Is 3. When you add it together is what? 8 valence what? Electron. 8 what? Electron. So my V, which called valence electron, is what? Is 8. Now, nitrogen will be the center atom. Do you get that? Because hydrogen cannot be the center atom. And whereas I have 3 hydrogen here. So nitrogen will be the center atom connected to what? 3 hydrogen. Connected to what? 3 what? Hydrogen. This is that. Connected to what? 3 hydrogen. So from here now, here I have what? 3 bonds. So each of hydrogen are connected to what? Nitrogen with a single bond. So yeah, because here I have 3 bonds, that is I have what? I've used 6 electrons. Do that. So my remaining electron here, remaining electron is equal to what? 8 minus 6, which is what? 2. Do you see that? So the remaining 2 electrons will now go to the center atom, which is nitrogen. Remember, nitrogen was have octet. Already it's already having 3 bonds, which was 6 electrons. So these 2 electrons will have to go to this other one here. So here I have this is that. So this is the Lewis structure for what? Ammonia, NH3. So you can see how easy it is. So the next one we want to do here, let's calculate formal charges. Formal charge. So formal charge is going to be what? Now remember, if you calculate formal charge of what? The hydrogen, you're going to be what? Remember, I told that formal charge equals to what? Valence electron minus line minus what? Dot. Right? So formal charge of what? Of hydrogen is very easy here. Now, what is the valence electron of hydrogen is what? It's 1. How many lines do you have? 1. How many dots do you have? 0. There's no dots. So that formal charge of nitrogen is 0. Now let's calculate formal charge for what? Nitrogen of what? Nitrogen. It's very easy here. What is the valence electron of what nitrogen is 5 minus. How many lines do you have? Here we have 3 lines, 3 lines, 3. How many dots do you have here? Here we have 2 dots, which is 0. That is, all the hydrogen are having what? 0 formal charges. The nitrogen are having what? 0 formal charges. That is why it is what is a neutral what molecule. Do you get that? So this is what the Lewis structure. Let's do on that one. So here we have SO3 2 minus. Good. Look at this guy here. So here we have uh, uh, SO3 2 minus. So VE. Let's calculate what total formal charge. Remember, the first two we have done are neutral molecule, right? But this one here is that what? Negative charge. Now, whenever you have a negative charge, you have to what? Add the magnitude to your total valence electron. So sulfur. Sulfur is what? Sulfur is what? Group 6. So it will be 6 times 1 plus. Oxygen is what is in group 6. So it's 6 times 3 plus what? 2. Do you see that? Now we are adding what this one here. Now whenever it's a negative, we add it. Whenever it's a positive, what you subtract it. So here we have 6 plus 18 plus 2. Here we have what? 26. Here we have what? 26. 26. Do you understand? Here we have 26. The next thing we want to do here is what? Sulfur is going to be center atom connected to what? 3 hydrogen. So here we have X, 1, 2, and what? And 3. Do you see that? Why is it 3 bonds? Because here we have 3 oxygen. So remember, 3 bonds. Remember, 3 bonds is equals to what? 6 electrons, right? So out of what my 6 electrons have, out of what my 26 electrons, I've used 6 electrons. So the 6 electrons have gone forming what? I've entered forming what? The bond. So remaining electrons is equals to what? Remaining electrons is going to be what? 26 minus here we have what? 20. This is that. So it means that I have 20 electrons left. So remember, all the atoms must have octets. There's no hydrogen, so all the atoms must have octets. This guy must have octet. This must have octet. This one must have octet, and super must have what? Octet. Do you understand? So for us to have octet, remember, it's already having a single bond. A single bond equals what? 2 electrons. So oxygen is already having 2 electrons. So here we have this one must have what? 6 electrons. That is 6 dot here, 6 dot here, and 6 dot here. So if one should take 6 electrons, 6 electrons, 6 electrons, out of the 20 electrons, I've used what? 18 electrons. Because we take 6, 6 making 12, 6 making what? 18. Do that. So out of the 20 electrons that is remaining, that is, do not take 6, 6 making 18. The remaining 2 electrons will go to the center atom. This that. So you have one, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. This is that. So out of the 20 electrons remaining, each of them have taken 6, is making what? 18. 2 will be left. The 2 now move to what? The center what? Atom. Just that. So when you look at it this one here, all the atoms now have what? Their octet electron. You get? Also you have the octet. Also you have the octet. Also you have the octet. Sulfur is having what? The octet. Just that. Now this is what is the Lewis structure. Do you get? This is what is the Lewis structure. However, now because here we have 2 minus. So what you have to do here, whenever you have a charge, after drawing the Lewis structure, ensuring that all the atoms have their octet electron, what you want to do here is to put a square bracket and put 2 what? Minus. This one equates what? The total formal charge of what? Of the molecule. Do you get? So now let's calculate formal charge of each of the elements. It's very easy. If I tell that formal charge is equals to what? Valence electron minus lines minus what? Dots. Right? So remember these 2 oxygen, they are the same because one, they have the same numbers of bond and the same numbers of what? Of line. Do that. They have the same numbers of dot and the same numbers of what of line. So if I should calculate the valence electron of the former charge of oxygen here, that is I've calculated for everything. So former charge of what oxygen. How do you do that here? It's very easy. Former charge is what is very easy. Now what's the valence electron of oxygen is 6 minus. How many lines do you have here? Here I have one line, which is what? One. How many dots do you have here? Here we have 6 dots. 1, 2, 3, 4, 5, 6, which is the electron. 6 dots. Give you minus what? 1. It means I think I go to be minus 1. I think I go to be minus 1. I think I go to be what? Minus 1. So formal charge for the 3 oxygen atom. So we can see that formal charge for 3 oxygen atoms. Sorry, it's 3 oxygen atoms. You're going to be what? Formal charge for 3 oxygen what? For 3 oxygen atoms. Going to be minus 1 times what? We're going to be what? Minus what? 3. Right? So you have to what? Take note of this one here. So now let's calculate the formal charge for what? Sulfur. Right? Formal charge of what? Sulfur. Now remember the total valence electron. So sorry, the valence electron of sulfur is what? Is 6. 6 minus. How many lines are you seeing here? Here I have 1, 2, 3. 3 lines. 3 lines. Minus. How many dots are you seeing here? 2 dots. It's okay. So when checkmate is very well. 6 minus 3 minus 1. What is what? Plus 1. Plus what? 1. Do that. So in the sense that if the checkmate is very well, the total formal charge what? Minus 3 plus 1. Do that because we're not to calculate the total formal charge of the what molecule. Therefore, you have to calculate the formal charge of what each of the elements that make that what molecule. They sum them together. So the total formal charge here for the molecule. Total formal charge is what? Minus 3 plus 1 equals to what? Minus 2. So minus 3 plus 1 is what? Minus 2. Where did I get the minus 3 from? Remember I told you that formal charge of oxygen here is what? Minus 1. Here going to be minus 1, minus 1, minus 1, which is what? Minus 3. Just that. Therefore, sulfur is what? Is what? Plus 1. So when you sum them together, going to be what? Minus 1. That is what? Minus 1. So, but if they ask in the exam, draw the resonance structure. So how did you get resonance structure for what this molecule here? So it's very easy. Resonance structure can be gotten. So let me write this place. Add. So resonance structure can be gotten for when the side atom they have what, a lone pair. Do you get it? So you can just move this lone pair to form a what? A multiple bond. So when you move this one here to form a multiple bond here we have. So when you move this one, here we have O. So here we have what resonance structure. Now, the main reason if you check very well, sulfur is having more than the octet electron. So the reason is because you got 3 elements like sulfur, phosphorus, silicon, chlorine. They can have more than the octet electron. Do you know that? Because they have expanded octet electron, so they can have more than the octet electron. So that is why we have it here. So whenever you may decide to what to move it from here, so that way instead of move from here, another person may decide to what move from here. So if you move from there, here have this is that. So another person may see that. So here we have 2 resonance structures. So this one is first resonance structure, second and third. So resonance structure is not like one complex stuff here. You just want to what, move your multiple bonds. You just want to move your what, lone pair to form a multiple what, bonds. That's everything about resonance structure. So let's look at another one here. So let's look at what CO3 2 minus. So let's draw the what the label structure for this guy. So if you should draw the label structure for this guy here, you have valence electron, right? Valence electron. How do you get valence electron? Now the valence electron of carbon is 4 because yeah, right, is 4. So it will be 4 times 1 plus oxygen is what is 6. So 6 times 3 plus 2. So you have 4 plus 18 plus 2. Here we have what 24. Here we have what 24. Remember, carbon will be the center atom. Carbon will be the what center atom. Connected to what 3 oxygen. So here we have 1, 2, and what and 3. This is that. So here I've used how many electrons? 6 electrons. 6 minus 28, here 24, here we have what? 18. So remaining electron, remaining what? Electrons. It's equals to what? 24 minus 6, here we have what? 18. Here we have what? 18. This is that. So now the reason why we have six electrons here is because here we have 3 bonds. So 24 minus 6 you give me what 18 what electrons. Remember, oxygen must have octet, oxygen must have octet, oxygen must have what octets. So if 6 go here, go here, go here, that is what 18 electron. I don't have any electron left. So here we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. Just that. So you can see that I have exhausted all my 24 electrons. You get so 24 still have much charge of this CO2 2 minus 24. Now when I draw this current here, that is connecting what the 3 oxygen to the center carbon with a single bond. Yeah, there's a you make the what 18 of what 6 electron. So 24 minus 6. So the remaining electron I have left is what is 18. Remember, the 3 oxygen must have octets. So here we have 6, here we have 6, here we have what 6. Make it what the 18. So that is, I don't have any more coming here. But they will say that all the atoms must have their octet. All the elements must have what octet. So how do I make here to be octet carbon? Because carbon here is obvious here is having what 3 bond. And 3 bond equals what 6 electrons. The will say that they must have an octet, which is 8 electrons. So it's very easy here. Is that what you move any of what the lone pair here? So if you do what move this one down here, here I have what oxygen here. This is that. So now you now have what the octet what electron. So these guys have the octet, this will have the octet, this will have what the octet. You see that? So now when everything is now with the octets, satisfying the total numbers of electrons of 24, then you have drawn the what correct label structure. The next one to do here, remember, is the negative sign here. So the only thing you want to do here is to what impute this one minus what 2. This is that. So how do you draw the second resonance structure? The second resonance structure is that now, although you move from here, another may decide to what move from here. If another decide to move from that point here, you are going to get a second resonance structure, which is this guy here. You see that? So now they are called resonance structure. So like what I said, resonance structure is not like one big stuff that should give you a decay. Now the only thing about resonance structure is that it's for me what multiple bonds at different points finish. So another may see decide to take from here. If I should take from here, here I have this is that. So here we have 3 resonance structure, 1, 2, and 3. 3 resonance structure. Remember, this is not a label structure because the carbon atom is not having what octet. So it's not considered as a label structure. Here we have 3. Here we have how many label structure? 1, 2. So how many resonance structure? 1, 2, 3. 3 resonance structure. So the next thing we want to do here is to what? calculate the formal charge. How do you calculate the formal charge? So here we have here we have two atoms here, or two elements. Now oxygen and what, carbon. But you can see that this carbon atom here is not like the other carbon. So this oxygen here is not like what, the oxygen here is not like what, the other oxygen here. This one is having two lines, that is two bonds. Here we only have what, one dot. So these two are the same, but this one are not the same. So let's calculate the formal charge. Formal charge, what, remember formal charge equals to what? Valence electron minus what? Lines minus what? Dots. Idea. So let's calculate the formal charge for this carbon first. Formal charge of what? Of carbon, right? So remember, the valence electron of carbon is what? Is 4. 4 minus, how many lines are you seeing there? How many bonds? 1, 2, 3, 4. 4 minus 0, because there's no dot here, right? You're going to give me what? 0. So the formal charge of carbon in this compound is what? 0. You understand? Now let's calculate this formal charge here. There is formal charge of what? Oxygen with this one here. So it's going to be 6 minus, how many lines do you have? Here we have 2 lines minus what? 4. Here we go to give what? 0. This that going to be what? 0. That is the formal charge of this oxygen and this carbon is what? 0. This that. Now remember, these two are the same. So what is the formal charge of what? Oxygen. The oxygen here. So here we have 6 minus 1 minus what? 6. Here we have what? Minus what? 1. So formal charge of what? Another oxygen here. This oxygen 2. 6 minus 1 minus 6 going to be what? So when you sum them together, 0 plus 0 minus 1 minus 1. Here we have the total valence of this result is minus 2. That is the minus 2 at this point here. Do you see that? So we still have more resonance structure, like more questions to solve, but I'm going to end this class here. So if you follow out this video and you understand what you have done, please give it a like and leave a comment at the comment section that this video is helpful and you want more of this content. Do you get that? So the goal here is what? For this content here that will be of help to you as you prepare for your exam. If you haven't subscribed to the channel, please hit that subscribe button. We still have so many level structure videos to come up and some other topics to come up. So please, you want to subscribe to this channel and give it a like. Please share with your friends if you know that it will be of help to them. Thanks for watching. See you in the next video.